In this lesson we will go over the variance and range of a group of numbers, and I'll show you how the variance, range, and average work together to describe statistically a group of numbers. And then we'll get out our calculators and I'll show you how to enter the numbers on the calculator. If you haven't already, please take a second right now and subscribe to this channel. And thank you for watching. Let's begin now on MathCat. 3, 2, 1. Let's look at the statistical measurements of range and variance. I have two groups of 5 numbers. Let's first take the average, x bar, which we find by adding up the numbers and dividing by n, the number of numbers, in this case 5. So let's add up these numbers and divide by 5. And the average of the first group, well, we have minus 10 plus 10 is 0, and then we have 0, which is 0, so we have 50 over 5. Average of the first group of numbers is 10. Let's look at the second group of numbers. Add them up. Divide by 5. On top we have 50 again. And the average of the second group of numbers is 10. So we have two groups of numbers. Their average is 10. But this group of numbers goes from 30 down to negative 10. This group of numbers goes from 12 to 8. So we have a much wider distribution of numbers here than in this group. So what else can we look at besides the average that would give us an idea of what kind of data we're looking at? And the answer is the range and variance are two other important pieces of information we can have to describe the data that we're looking at. So I've rewritten the average is 10 for both groups of numbers. Let's find the range. The range is simply the largest number minus the smallest number. So the range for this first group is 30 minus 10, or 30 plus 10, or 40. Let's do the same for the second group. Largest number minus the smallest number. 12 minus 8 is 4. So right away we can see that the range of the first group is 10 times greater than the range for the second group. Now let's find the variance. In order to find the variance, we have to find out how far each number is away from its mean. So let's create a table where x is the number in our group. And let's find out how far each number is away from the mean. That would be the number minus the mean. So here we have minus 10, and we're going to subtract 10, the mean. Minus 10 is minus 20. 0 minus 10 is minus 10. 10 minus 10 is 0. 20 minus 10 is plus 10. And 30 minus 10 is plus 20. Now notice if we added up all of our differences here, we have minus 20, plus 20, minus 10, plus 10, and 0. We would get 0 for a sum. And that makes sense because you're going to have just as many numbers below the average as you are above the average. That's the definition for the average. So what we're going to do is take this difference and square it. And that's going to make all these numbers positive and have a greater magnitude. So let's square minus 20. Minus 20 times minus 20 is positive 400. Minus 10 squared is positive 100. And now if we add up all of these numbers, we get 500 and 500, we get 1,000. So we have a number that's positive and of a greater magnitude. Now the formula for variance is this. The symbol is sigma, lowercase sigma squared. And if you remember, the symbol for a standard deviation of a population is lowercase sigma. Well, the variance is lowercase sigma squared. And I'm going to show you the relationship between variance and standard deviation as we go along. But the formula is this. It's the summation of x minus x bar squared divided by n, the number of numbers in your group. Well, we have x minus x bar squared right here, x minus x bar squared for each number. And the summation, capital sigma, this is capital sigma, lower sigma. So it's like a capital letter and a lowercase letter. But this means the summation. The summation of x minus x bar squared is 1,000. We just totaled up all of these numbers. So for our first group, the variation is simply 1,000 over the number of numbers in our group, 5, or 200. So let's write sigma squared for the first group is 200. So let's write down our x's and find out how far each x is away from the mean, x minus x bar. So we have 8 minus x bar, which is 10. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 10 minus 10 is 0. 11 minus 10 is plus 1. And 12 minus 10 is plus 2. And again, if we summed up these numbers, we have minus 2 plus 2, minus 1 plus 1, we would get 0. So let's square each one of these differences. X minus x bar quantity squared. So we have minus 2 squared is plus 4. Minus 1 squared is 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. And now we're going to sum up this column. So we have 5 plus 5 is 10. Now using our variance formula, the summation of x minus x squared, this is x minus x squared, and this is the summation, this is the sum of all these numbers, is 10. So in this case we have 10, and our n is 5. So our variance, sigma squared, for this group is 2. So let's look. The first group has a range 10 times the second group, and the variance is 100 times that of the second group. So even though the averages are the same, the range is 10 times greater in this group, and the variance is 100 times greater in this group. So by using the range and the variance, we get a better feel for the kind of data that we're looking at. The variance has the symbol sigma squared, and it's a summation of all the differences of x minus the mean squared over n. A standard deviation for the population has the symbol sigma, and notice it's the square root of the variance. That's why the symbol for variance is sigma squared, because the standard deviation is the square root of the variance, or the variance is the square of the standard deviation. The standard deviation is the summation of x minus x bar squared over n, and that's for the population, and for a sample it's n minus 1. Because of that, and we know the variance for each one of these groups, we can now simply find the standard deviation. The standard deviation for the first group would be the square root of 200, or approximately 14.14. And the standard deviation for the second group would be the square root of 2, or approximately 1.41. And that's the relationship between the variance and the standard deviation. On the calculator, we can find the standard deviation and then the variance by typing in two lists of numbers. Let's hit the Stat button and number 1, Edit. And if you already have data in your lists, you can clear it simply by scrolling up to the top, highlighting the list number like list 1 and hitting Clear, Enter, and that will clear your list. So let's enter this first list of numbers. Negative 10, it's the negative sign with the parentheses around it because it's a leading negative sign. Negative 10, 0, 10, 20, and 30. And for list 2, we'll enter our second group of numbers. To find the statistics for each number, we'll hit our Stat button. We'll go over to Calc at the top, var stats, number 1, and we want to find the var stats for our first list, L1. So it's second stat, and now we have the list names, L1, enter. And now we have the numbers for our first list. And the fifth number down is sigma x, 14.14, and that's what we calculated here. Now nowhere in this list is the variance sigma squared, so what you need to do from your calculator is take 14.14 and square it. So let's do that. 14.14 x squared, enter, and we get 199.94, which is approximately what we found with our variance this way. Let's find the statistics for our second group, which we already have typed in. So we'll hit our Stat button, scroll over to Calc, var stats number 1, and now hit second stat for our list names, and we'll go down to L2, enter, and enter. And now we have the statistics for our second group of numbers. And again, the fifth number down is sigma x, 1.41, that's what we calculated. And to find the variance, sigma squared, you take 1.41, x squared button, enter, and we get 1.99, which is very close to 2, which is what we calculated. So that's how you can use your calculator to get these same numbers.